Hello everyone. In this video, we are going to discuss about basic definitions in automata theory. The first one is alphabets. Alphabets are the finite non-empty set of symbols and alphabets are denoted by the notation sigma. The examples are the binary alphabet can be written as sigma is equal to 0, 1. Binary symbols are 0 and 1. So this can be represented by sigma. Sigma is equal to 0, 1 represents binary alphabet. And the second one is set of all lowercase letters. So this can be written as sigma is equal to A, B, C up to Z. So all the lowercase letters. So this is also alphabet. Similarly, we can write set of all uppercase letters, set of all digits, etc. Then next one is string. String is a finite sequence of symbols chosen from the particular alphabet. Normally, the strings are denoted by W, X, Y and Z. That is the lowercase letters at the end of the alphabet are called as or used for denoting the string. So W, X, Y, Z denote strings. So for example, if sigma is a binary alphabet, that is if an alphabet is 0 and 1, binary alphabet is considered, then a string can be framed from this binary alphabet, can be written as W. We can use any one of these symbols. So W is equal to 0, 1, 0, 1, 1. This is a valid string chosen from this alphabet. Finite sequence of symbols chosen from this alphabet is called a string. So we can represent it as W. Similarly, we can write another string X equals 110. So all symbols must be chosen from the corresponding alphabet. So these are the example for binary strings. Okay. So the next one is empty string. Empty strings are empty string means it is a string with zero occurrences of symbols. It is normally represented by the notation epsilon. 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 Epsilon represents empty string. That means the string with no symbols. The next one is length of a string. Length of the string is a number of symbols in the string. So it is normally denoted by modulus W. Length of the string W is denoted by modulus W. So for example, consider binary alphabet. So sigma is 0 and 1 and the string chosen from this alphabet is 0, 1, 0, 1, 1. Assume that 0, 1, 0, 1, 1 is a string chosen from this alphabet. Means then the length of the string is denoted by modulus W. So modulus 0, 1, 0, 1, 1 is 5 because the length number of symbols in the string is 5. Now assume that W is epsilon. That is empty string. If W is epsilon, then the length of the W is 0 because empty string has no symbols. Okay, string with 0 symbols. So the length of the string is 0 for epsilon. Next one is powers of an alphabet. Sigma to the power k is a set of strings of length k chosen from sigma. That is power of an alphabet is represented by the exponential notation. So sigma to the power k means we need to choose all the k length strings. Strings of length k must be chosen from this particular alphabet. So sigma to the power 0 represents we need to choose all the string with length 0. So for any alphabet, string with length 0 means it is epsilon only. So here for any alphabet, sigma to the power 0 is epsilon. Then let us take binary alphabet. So sigma is 0 and 1. So now sigma to the power 1 means we need to choose all the strings with length 1 from this alphabet. So the length 1 means 0 is 1 length can be chosen from this alphabet and 1 is a string with length 1. So only 2 possible strings can be chosen from this alphabet. Then sigma to the power 2 represents the set of strings of length 2 must be chosen from this particular alphabet. So there are two symbols 0 and 1. So length 2 means 0 0 is a string with length 2, 0 1 is also length 2, then 1 0, then 1 1. So these are all the 4 possible strings can be chosen from sigma for the length 2. Then next one is sigma to the power 3 means we need to choose all the 3 length strings from this binary alphabet. So the possible combinations are 0 0 0, 0 0 1, 0 1 0, 0 1 1, 1 0 0, 1 0 1, 1 1 0 and 1 1 1. So these are all the 8 strings can be chosen from sigma to the power sigma. So similarly we can write for all the cases. Then next one is set of all strings over a particular alphabet is denoted by sigma to the power star. So it can be written as sigma to the power star means set of all length strings. So 0 to the power 0, sigma power 0 union sigma power 1, sigma to the power 2 up to infinity. So if we have considered binary alphabet, then sigma to the power star, sigma star can be written as sigma 0 is epsilon, sigma to the power 1 is 0 and 1, sigma power 2 0 0 0 1 1 0 1 1 infinity up to infinity. That is set of all strings chosen from the particular alphabet can be written like this. Then set of non-empty strings chosen from the sigma means it is denoted by sigma to the power plus. So it has all strings except sigma to the power 0. So sigma to the power 1 union sigma to the power 2 union up to infinity. So it will contain all the strings except epsilon. So the relation between plus and star is sigma to the power star can be written as sigma power plus union epsilon. So if epsilon is added with sigma to the power plus, then we can get sigma to the power star. Then concatenation of strings, assume that x equal to a binary string 1011 and y equals 0111. Concatenation of strings can be written as x, y or x dot y. So this can be written as by copying x first, then it is followed by y, string y. So this is xy. Similarly, we can write yx. Yx means first we need to write all the symbols from y, then x. So this is concatenation. And suppose if we want to concatenate a string with epsilon, or epsilon is concatenated with string w, then we can get w as a result, because epsilon is an identity element during concatenation. The next one is language. Language means set of strings chosen from the some sigma star. Sigma means it is an alphabet, and language is denoted by L. So some examples: language of all strings consisting of n zeros followed by n ones for some n is greater than or equal to 0. So we need to write L. Here the alphabet is 0 and 1, right? So 0 and 1 means we need to take the binary alphabet. So the language of all strings consisting of n number of zeros followed by n number of ones for some n is greater than or equal to 0. So L language means set of strings should be written over here. So first n is greater than or equal to 0. So if we consider n as 0, 0 zeros followed by 0 number of ones. So 0 number of zeros followed by 0 number of ones means the string with no symbols. So epsilon. Then 1 consider n as 1. So 1 number of 0 followed by 1 number of ones. So 0 1. Then 2 zeros followed by 2 ones. So 0 0 1 1. Then 3 zeros 3 ones, etc. So this language represent epsilon 0 1 00 11 000 111 etc. So these are all the set of strings in this particular language. Then second example is a set of strings of zeros and ones with equal number of each. So we have to write all the strings with equal number of zeros and ones. So epsilon is also a correct string because it has zero number of zero and zero number of ones. So here also number of zeros and ones are equal. Then other combinations, 0 1 is a valid string because it has 1 0 1 1, then 1 0. Here also number of zeros and ones are equal. Then we cannot write string with 3 symbols or string with 1 symbol. Odd number of symbols, odd length of string cannot be included in this example because each string should have equal number of zeros and ones. So next we need to consider the strings with length 4. So 0 0 1 1 is a valid string. It has 2 zeros, 2 ones. Then 0 1 0 1, 1 0 1 0, etc. So these type of strings must be included in this language. So this language has all the strings which are having equal number of 0 and equal number of ones. The next one is the set of binary numbers whose value is a prime. So we need to write language. Language consists of set of all binary numbers whose value is a prime. So L is equal to first the binary first prime number is 2. So 2 binary equivalent for 2 is 1 0. Then 3, so 1 1. Then 5, so 1 0 1. Then 7 is a binary alphabet. So 1 1 1. Next 7 is a prime number, so 1 1 1. The next prime number is 11. So the binary number for 11 is 1 0 1 1, and so on. So this language has all the binary numbers whose value is a prime. Then the final one is empty language. Empty language is normally represented by 5, and it has empty language means it is a language, it has no strings. This language has no strings, so it is represented by 5. So these are all the basic definitions in automata theory. Thank you.